In 1859, Charles Darwin published On the Origin of Species, and he attempted to do two things in this book. First, he wanted to persuade the reader that species had changed, and this was in contrast to the special creation hypothesis that suggested that God had made species in the past and species had never changed since their creation. So Darwin will reject that, and he will lay out different categories of evidence that species had changed. In addition, Darwin will argue that the driving force of this evolutionary change is natural selection. But in this lesson, we'll look at the first category of evidence that species changed. We'll call it Exhibit A, the fossil record. Now, in Darwin's time, there were fossils being found all the time, although the fossil record today is much better than in his day. Nevertheless, people were well acquainted with fossils. After the Industrial Revolution, when people were digging canals and digging mines and quarries, lots of strange shapes seemed to be preserved in the rock. So sometimes the strange shape was the impression of an organism, and sometimes some part of the organism turned to stone. So these are different kinds of fossils. But fossils seem to be snapshots of the past. They captured living organisms as they existed in the past. Now, it's one thing if you find a fossil of a fish and you might say, well, maybe it still is swimming around somewhere. But not these things, right? So the dinosaurs were just incredible fossil finds. So these things clearly were not living on Earth in Darwin's time. And that suggested then that these species here and the many, many, many species found in the rocks had gone extinct. So fossils indicated that many species that once existed, like these dinosaurs, were now extinct. And that fact alone suggests that life had changed on planet Earth. Now, when Darwin set sail from England on the HMS Beagle on his 5-year journey around the world, he embraced many of William Paley's ideas about species. So, like other Christians of his day, he embraced the idea that God had made species in a separate act of creation at some time in the past and that they had not changed. So this is an important point. Darwin, when he began his journey, he was not a radical thinker. He did not think that species changed. He thought they were immutable, to coin his word. However, of course, after 5 years on the journey, he's going to begin to doubt this idea. And one of the things that he encounters along the way in his journey are lots of geological features of the planet. And in addition, he will find many fossils. And he will become convinced that the Earth is very old. Now, the geologists of Darwin's day also believed that the Earth was older than the Bible said, but nobody really knew how old the Earth was. Darwin will convince himself that the Earth is very, very old indeed. For example, in South America, when he trekked up the Andes Mountains, he found fossilized sea creatures, right? So these shells. Now, if you think about that, that's kind of strange because these are sea creatures, yet he's finding these fossils on the tops of mountains, right? Thousands of feet above sea level. Well, how in the world did they get there? Now, one possibility would be that perhaps long ago in the past, these creatures were living in the ocean, and somehow the ocean floor was pushed up to form the mountain, thereby carrying with it any fossilized creatures fossilized sea creatures up to these great heights. Well, if that's the case, it makes you think, well, okay, first of all, what kind of force could do that? But secondly, how long would that kind of process take for the ocean floor to be pushed up to the heights of mountains? Well, we can begin to see some answers to those questions when on his journeys he actually experienced a very, very strong earthquake in Chile. It killed people at the time, but notably, it elevated some of the land masses around the area of the quake. It elevated the land masses a significant extent. So, for example, take this coastline here. After the earthquake, Darwin found mussels, putrefying mussels. You know, they normally stay attached to the rock, but usually they're in the tidal zone, so the ocean water washes over them at high tide. Well, these mussels were 8 feet above sea level. In other words, the earthquake had the effect of elevating, rising up the landmass 8 feet. One earthquake pushed this bit of land up vertically 8 feet. Now, right here then is one of the answers to the previous question. What kinds of forces could push an ocean floor up to the heights of mountains? Well, earthquakes. So whatever earthquakes were, they were forces that had the power to elevate land masses. Now, with respect to how long would that kind of process take, well, here we have an 8-foot elevation change. Now we have to think about, well, how frequent were earthquakes? Well, these really strong ones are not that frequent. And so if we just kind of do the calculations, if you're kind of pushing, the rocks up at a few feet every 1,000 years, let's say, well, then it's going to take a long time to push the ocean floor up to the heights of mountains. So it's these kind of considerations that led Darwin to argue that the Earth is extremely old. But that has important implications. So just as mountains can rise by small increments over vast amounts of time, Darwin began to suspect that so too small changes to species over vast amounts of time might create very different animal forms. So here the idea is, if the Earth can be transformed in really big ways by small processes happening over vast amounts of time, leading to very big differences, like a mountain instead of an ocean floor, well, then perhaps the same thing was happening to living things, that perhaps species were changing over time. To give an example of this, consider this creature right here. This is Glyptodon. Now, it's an extinct creature, and Darwin found fossils of this organism in South America. Now, it has many characteristics in common with today's armadillos. In fact, today, armadillos live in the same region where Darwin found these fossilized creatures, these extinct creatures. So it occurred to Darwin that perhaps Glyptodon was the ancestor, the extinct ancestor of today's armadillos. But wait, if that's the case, notice the size difference for one, and other differences as well. But it suggested then, if Glyptodon was the actual ancestor of armadillos, that change had happened. So Darwin began to entertain the possibility that species today had ancestors that might not have looked exactly like today's species. And that suggests that species were changing through time. Here we see a very significant change just in size. And again, then if we use the analogy of small changes over vast amounts of time can create mountains, well, then Darwin's suggesting small changes in species over vast amounts of time can create big differences between today's species and those captured in the fossil record. To give another example, something that Darwin did not examine on his voyage around the world, but this is the Grand Canyon here in the United States, and here we see some sedimentary rocks, and you often find fossils in sedimentary rocks. Here we see a closer-up view of sort of the layering that you see here. And the way geologists understand this is that as you go down, right, the layers here, we're traveling back in time, because sedimentary rocks form by sediments that kind of wash over each other and then harden into rocks. So the upper layers here would be the more recent rock layers, and then as we go down through these layers, we're moving back in time. So consider what we find in rocks fairly high up in this layering here in the Grand Canyon. You'll find lots of different kinds of vertebrates. So, for example, we have birds and mammals and reptiles and amphibians and fish in the upper layers. But now if we go deeper, so we look at some of the lower layers, so the layers that are just below the upper layers here, here's what we find. We find reptiles and amphibians and fish, but the birds and mammals have disappeared. In fact, if we go even lower down in the rock layers, again, the idea is going back in time, we find fossils of amphibians and fish, but no reptiles, no mammals, no birds. And if you go even lower, you find just fish. So the idea here is that as we travel back in time, the fossil record seems to be painting a picture where species were disappearing. Well, let's just run the story the other way around. At one point in time, the only vertebrates that existed on Earth were fish. And then sometime later, there are fish and amphibians. Well, that raises a question. Where did the amphibians come from? And again, just this idea of the different layers of rocks containing different kinds of creatures argues or suggests that species are changing. Something is happening to produce amphibians. Now, Darwin's going to argue that some fish evolved over long periods of time into amphibians. Now, some fish stayed fish. That's why we still have fish today. But some fish long ago were changing into today what we call amphibians. And then some of those amphibians evolved into reptiles. Of course, many amphibians stayed amphibians, but some of them went through evolutionary change to become new kinds of creatures that we call reptiles. And some of those reptiles evolved into mammals and birds. So here again we see this idea that the fossil record is painting a picture of species, new species emerging on the planet, as well as species extinction. Now, if we go way down deep into the rock layer here, we don't have any vertebrates at all, but we do find creatures like this trilobite and other types of organisms. So these marine creatures existed some 500 million years ago, over 500 million years ago, but at this point in time there were no vertebrates. So the first vertebrates that the fossil record captures would be the fish. And from fish, we have this tremendous evolutionary diversity of vertebrates on the planet. And so that now we have fish and amphibians and reptiles and mammals and birds. Now notice then what this suggests. Here we have a diagram of this pattern in vertebrate fossils, where the younger rocks have all of the 5 major categories of vertebrates, and as you go back in time, we lose different kinds until we get back to old rocks that just have the fish. It suggests that species had changed, that new types of organisms came into existence. And let's compare that to what Paley would have suggested. Remember, if God had created all the different species at some point in the past, then we might predict that all of the different vertebrates would be present in all of the rock layers. So notice the prediction of the special creation hypothesis is different than the actual fossil record. The actual fossil record weakens the special creation hypothesis. In summary, then, the fossil record supports Darwin's claim that species had changed over time, and it weakens the special creation hypothesis. So we'll see in another lesson some other implications of this idea of species change, and whether the fossil record supports the idea of species change or does not. And again, Darwin will argue that the fossil record supports species change because it actually has captured some of these transitions from, say, fish into amphibians, and amphibians into reptiles, and reptiles into mammals, and reptiles into birds. So the fossil record not only paints this picture here, but has actually given us creatures that seem to be in a transitionary stage, sort of capturing this evolutionary transition from one type of organism to another type of organism. And we'll see that in another lesson.